Hello and welcome to New Geometry. It's George Leoniak and I have some exciting material for you today. It's going to be getting into more on the golden rectangle, the golden spiral, and how that all integrates into the golden vector matrix that I've been sharing in some of my other videos. We're also going to really walk through some steps of how this can be easily drawn, the golden rectangle. So we're really going to get back to basics on this, right into the vesica Pisces. I'm going to turn this diagram from 2D into 3D for you. And I'm also going to go over some of George Odom's work. This was going to be a tribute video to him, and it just kind of blossomed into a lot of other things too. But I'm going to include some of his groundbreaking material that is really revolutionizing sacred geometry and how it can be applied to our classic drawings. So let me share my screen and enjoy me for this video and enjoy the video. The Golden Frontier of Sacred Geometry was the last video that I just did. And I recommend checking it out if you haven't already, because I'm going to be going over some things that are related to it. And this is actually a three-dimensional form, just so you could see that it's constructible, and it's a cubic-based system that is all golden ratio points that are creating all these other vertices to create the icosahedron and dodecahedron. And we're going to infuse the spiral into this, and I'm going to get to that a little bit later on. So I'm just setting the groundwork with that because we'll be revisiting it in just a little bit. But first, I want to go over these three revolutionary discoveries by George Phillips Odom Jr., 1941 to 2010. He was an artist, an amateur geometer. He spent time working with Coxeter and sending his material. He did a lot of work with the phi ratio, and these are some of the amazing discoveries. This one was primarily what I discussed in my last video of how to construct a golden ratio, A to B to C would all be in golden ratio on an equilateral triangle within a circumscribed circle here. So that was one of his, and I took that simple technique there and built the whole thing. I have a couple slides up here, a whole new circle pattern based on that. And then there was this one over here of how to also use an equilateral triangle and also divide a line into phi. I'm going to talk a lot about that one in this video, as well as this one. If we visualize this as a cube and we send from the center face of this cube through the center face of this upper face here, it will touch the surface of the sphere, and A to B will be in phi proportion to B to C. And that is relating it now to 3D geometries. We're going to turn everything of these 2D diagrams into 3D, which I love to do. This was from my last slideshow, the Golden Frontier video. And here's the equilateral triangle method. And the thing that I'd like to say about this, and I'll discuss in a couple more slides, is that when we remove the basic pattern from the other circles that create the geometry, they kind of take the sacred geometry part out of it. And it just becomes about the division of this line. But this is obviously right. In order to get that equilateral triangle, we need to create the seed of life to do so. And then what I did here is I created this whole awesome circle pattern based on doing that in all the directions on the outer sphere around the seed of life. And I did this for a very specific reason, because it led me to discovering how all these Platonic solids and other forms like the icosahedron, cube octahedron, rhombic dodecahedron, star stellated forms of the dodecahedron, rhombic tricontahedron, all could be all the vertices are found within this matrix that was basically just set up from this essential design. That's all very much in the other video. We're going to actually go more to what I call the square view, which is more of a cube on a flat face, square facing you like this, because in the flower of life or in the seed of life view, golden circle seed of life view, that cube is vertex oriented to you. And we're going to go to square version of the cube like this, although it looks just like a square. So, you know, it's easy to just look at this as a 2D drawing. And, you know, when I look at this by itself in isolation, it's hard to see where the rest of the geometry that constructed, like where are these circle arcs going? It's how do you get the equilateral triangle? Well, of course, I knew that the equilateral triangle is created just from the very first steps in sacred geometry is to create that vesica Pisces. And once you get that, you can create your central line off a horizontal line, central circle, do your equilateral triangle. And all you have to do is extend that line out and you have your phi division, AE to F. AE is in phi to FA. Amazingly, I discovered this on my own last summer. I'll show you the slides, but I turned it into a golden rectangle right away, rather than just focusing on the isolated portion here. So my drawing that I did last summer fits right over Odom's drawing. It's just that I use these techniques, which I'm imagining that George Odom did too. And when he sent this off to Coxeter, HSM Coxeter, Howard Coxeter, the great geometry, the king of infinite space he's called, or at least that's what his book is called, The Man Who Saved Geometry. He was in communication with it. And at that point in time, Odom was living in a psychiatric center, you know, because he tried to take his life at some point. But these discoveries are really all from the 1980s, pretty much. So they're really integrating into sacred geometry, and they're in the field. And I just happened to come upon this on my own, because what I did was I just drew a circle around the vesica Pisces and just extended the line and realized that was phi. Of course, I had to test that out to make sure, but now it is definitely verified because Coxeter did these drawings, or at least tested this to verify Odom's research. So the video was going to be entitled On the Shoulders of Amateurs, which I might still call it that, but it's yet to be decided, because there's a lot of amateur geometers out there who are fascinated with phi, making incredible discoveries like new geometry here, putting out this video 10 months ago, how to draw a golden rectangle and spiral. And in 10 months, just 135 views and 5 likes. So check this one out if you want to learn how to draw this very simple method, which I just did with my apprentices this past Monday. And I've just done it on the 45-degree angle here. And in the video, I rotate it so it's flat to the horizontal line. 2 different ways to do it, but this will just go right to the square root of 3, that outer circle, and it will contain the 1-inch circle that the square is within, and this will produce a beautiful golden spiral. So check that one out. It's on YouTube under Doing Sacred Geometry playlist. So back then, I mean, the steps were already getting lined up for me to make some more of my discoveries, but I was really just seeing that as a cool 2D discovery. I didn't see how the golden spiral, the golden rectangle at that point was fitting into the 3-dimensional geometry. So here are the steps. I'll overlay them right now for you. Well, we draw our 2 circles, a horizontal line, the vesica Pisces is created. Draw your circle in the middle, which is in the vesica, and draw your circle around the vesica. Then make a square. But, you know, next step, we will just make our square extended till it touches the blue vesica. And we do that on both sides. Draw a little cross piece here, right, to finish off your golden rectangle. Now we have a large golden rectangle and a small golden rectangle. And this is the interesting thing. When we locate the point of origin of the spiral, it's at this cross point. And that is going to be a very interesting question throughout the remainder of our topic or discussion today, is that point is the origin of the spiral. It's right on the circumference of this unit 1 circle. It's right on there, and this software here shows me that this point will be exactly on the circumference of that circle, meaning the origin is on, this spiral's origin is on the 1-inch circle. The 0.5 diameter, radius, 0.5 1-inch diameter circle. that blew me away then, and I talk about that in the video. But this is where I'm headed now, because this is where it gets really interesting. Because the other Odom discovery that I've also been drawing for quite a while now, but it just dawned on me that when I actually saw George Odom's drawing of this, or whoever did the drawing, but his discovery that was tested out by all those guys, this is now actually thinking that this is a cube. This is not a square, this is a cube. And this is going to be an octahedron over here at step 6 within a black square, which is now a cube. And now when we extend that line of the octahedron edge, right? So this is an edge of an octahedron that goes out to touch the blue circle. Now, all of a sudden, we turned our golden rectangle into a 3-dimensional geometry. And like I said, I've been drawing this for a while, but it never really dawned on me how simple this is. And I've got some steps that are going to show more of that. So in order to get your next steps here, step 5, to get your square, very easy. Take your central circle, which you just put right in the vesica, right? And then you take that circle and you put it up over here on the top of where it intersects a circle, and draw 4 more circles, and you get these 4-leaf clover thing going on here, right? So you've got the 4-leaf clover. Now just draw, connect the dots on those, and then you've got your square. Now this was mind-blowing to me because I didn't even realize this for all these times. And it really comes down to most sacred geometry books that you've ever studied or look at. They never really put a circle around the vesica. But what that's essentially saying is this. Here's a cube in a sphere, right? I've got this cube in a sphere, and it's an optical illusion because it looks like the edges of it are not touching the surface of the sphere, which is here. They're floating down in there. And inside the square root of 3, is a number 1.732. Okay, it's a sacred root in sacred geometry. This is what the vesica produces. Vesica Pisces produces this. That is the inner diagonal of the cube from the vertice to vertice through the center of the cube. So if I turn it this way for you, from this corner here, here's an edge, corner to corner through the center, as if it's spinning on its 2 vertices, like Merkaba style, that is the square root of 3. Now that means if I put a sphere around this, it will be touching all the vertices of this 8 vertices of this cube. And essentially, this is a 1-inch edged cube, and this is root 3. So it dawned on me like a ton of bricks, you know, because it was golden bricks. Because all of a sudden I was like, wow, that square is a cube that is actually contained already inside the sphere of root 3. Okay. I don't know why it took me years to figure that out. Maybe everybody else out there who's a geometer is just like, oh yeah, that's the way it always has been. But to me, it was a bit of an epiphany after all these videos I've been doing of very complex forms, that's how simple it was. And now we just extend the octahedron edge and we get the golden rectangle. And the location of the sphere that's in the cube and the octahedron around it, that is the golden rectangle and this origin of our golden spiral. So here's our spiral going around. And of course, it would be a smooth spiral, but as you draw it in geometry and putting it in these squares, which are golden ratio squares, it is kind of quarter arcing itself around. Nevertheless, it will continue past here, and you can visualize this coming out towards you. But we're just using these squares as kind of a 2D origin, reference points. So, oh, nice, gone a little out of order in my slides there, but that was the spiral that was created from there. And so we've done the 3D thing a little bit, but let's take the 3D a little bit further. So I'm back to step 6 and step 7. So we've got our octahedron in our cube, we got our golden rectangle. Now I'm going to have some fun with the golden rectangle. I'm going to go over here. I'm going to do one golden rectangle here, here, here. I've got 4 of them. And then I'm going to connect those little crossbars. I'm going to do all the lines in all the directions and come up with a cool looking pattern. But then I'm also going to now extend the line across here and create a kind of octagon type shape, 8 sides. And that actually, when I do that and extend the line up, remember, this is now going to divide this in from the vesica. It's 1.732 along the whole length. But now I've divided this line from blue to red in the phi proportion right here. So I've got another division of phi right here in this drawing. And I wish that was a little more close up for you. I'm going to draw these long lines, and this is all leading to something, and I'll show you in just a moment. So after doing these long lines, I'm going to draw one dodecahedron first, because the top of the dodecahedron is across that line and extends down to the outer lines that were given over here with the golden rectangle, and then extend those lines down so that they will give me the 0.618 bar across here, and then connect the lines, and now I've got my dodecahedron that is having one cube. So I've gone from 2D of looking at this as a square to looking at it as a cube with an octahedron to producing 5 cubes, all within our relationship to our fundamental basic pattern. The vesica Pisces 1.732 square root of 3 is containing a dodecahedron. This is the basics back to the creation, and the ether form is right in there. Well, you're saying what's going on with the icosahedron? Well, I could put the icosahedron inside this. I could extend it outside 1.732, but it does not share root 3. It's going to be a little larger or a little bit smaller than that, but this is just kind of how it works out. Then we got to the 9 cubes of the mated pair of dodecahedron, and they are sharing the 1 cube in the center here. So they're both sharing this cube. And there are 5 cubes in the dodecahedron. So if they're sharing one, we've got 4 for each of the 2. So we've got 9 cubes in this. And all I've done here really is just because all the points are given in here at step 9 to do 2 dodecahedron. And I showed the 2 dodecahedron in the previous Golden Frontier video, where it's from the vertex view. Now I'm just showing what it would look like from this view. But see, this gives rise and birth to a whole new form, because when 2 mated pair of dodecahedron come together, you can connect those 2 vertices and you get a new form with golden hexagon edges. And that's what this looks like. So all the edges of the shared vertices of the compound of those 2 dodecahedron will end up looking like this in the square view. So this is where the crisscross of the 2 dodecahedron are. And when you connect the lines across, we've got these edges here that are going to be in golden proportion. And then we've got these edges, which they are just meeting at the vertices here. They're going to be a little bit different in length than these golden hexagon edges. Don't have the correct exact value for you. And this is the golden hexagon from this view. So now if there's any form that I would say that's been the most expansive in my understanding of sacred geometry is working with the golden hexagon, which does have 120-degree angles, just like a regular hexagon, but it has golden proportion edges, right? So if I extended this out, it would make a golden rectangle. So this is just a kind of neat form that came about last summer. I did this one before I even had the iPad and could check everything out very well. I saw that this was a possibility, but I had no idea that it was going to be leading to be found within my most recent megastructure here, which is the golden matrix, the cubic style version of this. Like I keep saying, I could turn this all into 5-fold symmetry, but I'm just going with thinking of these as cubes. But there are those 2 dodecahedron within these vertices. So this is a photograph of this structure, which if you're looking at a vertex view, it would look like this. And now that contains the reason why these, it looks like just cubes together, but we've got these open channels through the middle. The open channels are here. We've got octahedra of different sizes being created. We've got all sorts of scale invariants going on through this whole thing. It's very different than the isotropic vector matrix, because this golden matrix will contain that scale invariance of the golden ratio, as well as unequal edge lengths. So it's got some disequilibriumness, but it produces these 2 dodecahedron at these vertices and 2 icosahedron in a compound at these vertices. So I've been meaning to share this little form all the way since last summer, and the icosahedron one, which I've done a little bit more. Here it is. So here's the icosahedron version of the two. Those lines on there are the two icosahedron that are crisscrossing, producing this one. It's basically like a truncated octahedron. Same thing here, except we've got the cube edges sticking out. So finally, I'm getting in these video about 8 months to 9 months later before they're coming out. But you see, the rest of the matrix had to be discovered that this is not in isolation. It's part of this whole network. So that's the big thing with the golden vector matrix. These little spaces and gaps that you see here are essential to creating the two missing Platonic solids that even Buckminster Fuller kind of left out from his models, although he used them quite extensively in his geodesic domes, but they weren't in his cosmic hierarchy diagram. And some researchers of geometry feel that that was a kind of missing component to it. So, component to the way he described a cosmic hierarchy. Okay, we're going to spiral back around to my big question with all of this. So here's our spiral. I just put it in the dodecahedron. That the dodecahedron is in the same drawing as before. Not much difference there. But the big question is this. I had to go 3D. So I had to learn these skills in less than 12 hours of going to the Geogebra 3D calculator version of this. And magically, I was able to just draw sacred geometry in there, not even really knowing what I'm doing with this program, but I did it anyway, and it worked out because what I needed to figure out for this video was, here's our 2D perspective drawing. Here's our cube, right? Now, it looks just like a square because remember, this is what I call the square view. This is why I call it the square view. And it looks like a square, but we know now it's a cube. Well, I'm going to show you it's a cube in a moment as soon as I rotate this, which I'll do on the iPad at the end. We've extended the lines out. Here they are meeting the surface of the sphere. Now that was tested by mathematicians to verify that. And now the question was, okay, we know this section meets up as well in the program, and we'll zoom in on that when I get to the program to check that out. So that worked out, okay? That was connected also. So that cross section meets on the inner red sphere. But what happens if I rotate this like to a different view in my drawings? I wanted to see if the drawings were accurate. So here was my question. I wanted to know, is that the surface of the sphere? So here's my octahedron, which I used the square view, and I isolated one of the cubes in that dodecahedron, which was not at a regular square view. It was at a tilted view in the dodecahedron. I redrew the octahedron within there, extended the lines out. So these are touching the surface of this blue sphere, okay? We've really tilted our whole angle. And now we're doing our crisscross of lines here. This red line is actually below that blue line to a back side of the form here. But this is, does this spot where they cross, does that circle, is it actually a sphere? You know, because this will change one's perspective of every circle they draw in sacred geometry, because you might actually start to see them as spheres if that point, well, at least for me, if I start to see that point as it's actually lifted off the page a bit, it's not just a flat circle anymore. It's actually like here's our octahedron in a sphere, and here's a square view. And now what I've done with this octahedron is kind of tilted it along like that. So you're kind of looking at it like that. So now all of a sudden, those points of the octahedron are not going to appear that they're in surface contact with the sphere. See, they look like they're floating inside. So it should follow that this point will be on the surface of the sphere, which means that that whole square view is not just squares and circles, it's octahedron and cubes and whatever else forms we want to draw there. So here I go. I'm going to test this out. I'm able to rotate this now, and I get to the best of my ability to line up the visual perspective of my drawing. And this is why it's so key for the in my other videos, I talk about correcting the view of the dodecahedron and the icosahedron, you know, to this isometric perspective, because when you start to apply it to actual sacred geometry rather than that dodecahedron that's Metatron's cube, you will not be able to do any of this. If you like that as a kind of artistic representation of it, that's great. But when you start to do sacred geometry, where you have to ask questions about these sort of things and figure out if this point on the sphere is correct, we need to have the blueprint, the correct blueprint of the Platonic solids to do this work. So here is the golden rectangle at this angle, and then all of a sudden I'm going to do my line, and yes, this is a crossing here. So here's the yellow lines. Keep an eye on this because I'm about to move this, my drawing, which fits perfectly over top of that other version there. The yellow lines are going to stay in place. And I can move those too, because underneath these yellow lines, which are all lined up, right, are the dotted lines of that point. Right? So all that was just laid out very nicely, one over top of the other, so that we're able to see that that point is meeting the surface of that sphere. And this is a three-dimensional geometry program, which is showing me that. There, lay them all back over one another. And that little circle that I drew with my big question, is that the surface of the sphere? Yes, it is. And I did it from this perspective too. So I did it from our Metatron's cube perspective, the golden circle seed of life perspective, but now I'm focused on the cube, drawing a cube just as if it's a tetrahedron inside it. Here are the blue edges of the octahedron, and some of them are now been extended, right? So the lighter gray ones here are now going to be that golden rectangle. Here's my little cross section, because that's how you find the origin of the spiral. So rather than that circle, remember in my previous drawing where we've got that all nice and lined up, like there it is, right on the edge of the circle. But in this one, it's right here, floating out in the middle of space, you know, like in a circle, there's a dot. But that dot in the circle is actually part of a curved space. And sacred geometry is bringing me to this through my drawings, because here are the drawings. I'll show you how I got this drawing in just a moment. There's my golden rectangle. There it is on a tilted view. Not many people, you know, not often you see a drawing of a golden rectangle like this. It's supposed to look more rectangular and long rectangle with the golden proportions, but this all maintains the golden proportions to be able to accurately fit into this, because it's right here in the three-dimensional drawing. And I'll move this out of the way and we'll reveal the dotted lines just underneath the yellow. Oh, I don't want to take that one. Undo the nudge. Let's nudge this one. There it is. That was the point P right there. Let's put it back on. I could do a better job for you than that. So it's back on. Move it again. Right underneath there are the dotted lines. Okay, I think you get the point. I tried to test this out as best as I can. I hope someone else will look at it with a scrupulous eye who can even go further into the mathematics than I. It just all lined up on my drawing iPad, and I did it all on this here. And these spheres do look in contact to probably a 99.something9% accuracy. Here's the drawing, and I guess the real point is that the sacred geometry gets you into this contemplative state. It gets you asking these types of questions, because this is all going to mean something in a little bit. I just haven't gotten there yet. So this is the golden circle seed of life, and here is the golden hexagon or golden rectangle in the hexagon view. And here's my purple lines of the crisscross. And this doesn't actually hit this phi ratio circle, but it does give us another circle that's just outside of that to give us the exact point. So that's just a little note. But all I needed to do for this drawing, and this is why the golden circle seed of life is so important to even draw this hexagon. Here's the black cube, here's the octahedron, the blue. And then I just extend these lines out to where they intersect the edge of the golden the hexagon here with the phi ratio circles. See, this is what this does for us, these golden circles in here. Chris, there, go there, extend the octahedron edges out to those lines, draw a line across, and there it is. That's a golden rectangle drawn in a tilted perspective, probably undone in sacred geometry drawings. But with the golden circles, like I say here, it just keeps on sprouting new possibilities for us to discover. Because when you're working with the phi ratio and golden rectangles or dodecahedron and icosahedron, and phi ratio is mixed in and woven into so many things and patterns, why not put them in the seed of life? You would think the seed of life would have some phi. Okay, so let's go and look at this. We're going to change it up a little bit because I want to take that information and place it into the golden matrix and really just show how many different circles of octahedron in here. And I want to just visualize in your mind as best you can, like any point on any of these octahedra, because basically what I'm saying here in all this is that on the surface of a sphere that is around an octahedron, okay, like this one, and here's your octahedron in a sphere. It doesn't mean that just one point on this sphere can be a golden spiral emanating from there. Any point on this sphere, an infinite amount of points on this sphere. And it really brings into question like what a point is. You know, when we're hunting around trying to find what a point is, if we zoom further and further into that point, maybe it's an octahedron in that, you know, maybe there's some geometry in a point, and maybe it's at every center of every point of a spiral, like where's a spiral or originate? That's like Cathara, Keylontic science, big thing about the crystal spiral originating from the center. Well, where is the center, right? So this is the quote that we often see is, you know, God is a circle, you know, whose center is everywhere and whose circumference is nowhere. But I found the quote from 24 philosophers here. This is the book that probably it may have come from. There's probably different sources of this, but this one is God is an infinite sphere whose center is everywhere and whose circumference is nowhere. So we're thinking now, instead of these being circles on this, they're spheres. And because I'm working with the scale invariant octahedra here, there are 1, 2, 3, 4, 5, 6 different, well, let's do on the count one more time. 1, 2, 3, 4, 5, 6, 7 different size octahedron. This one would be part of this octahedron that's going way out here. And this would octahedron edge comes over here, and this one comes up, and they produce a little baby octahedron. And there's a lot of that crisscrossing of octahedron, and it's all interwoven. So this was the visualization. You know, it's like, if that golden spiral can emanate off of any point within this, on these surfaces of these spheres, which look like circles, that's a lot of golden spirals through this. I mean, the golden matrix, just like this thing I worked on building for a while, which is probably made up of the golden matrix anyway. But this is my best cardboard representation of what I'm trying to articulate here. If these are all spheres and golden spirals coming off this is just some sort of grid work to maybe show just a fraction of what's possible. But when you turn every sphere into the possibility of being a point that you can infinitely go into, and that point could emanate spirals in every single direction continuously, either inward or outward, then I think we're getting maybe a little closer to visualizing what the interwoven pattern of interconnectivity and wholeness might be happening at. And that's probably all happening in a point anyway. So anyway, this is it's everywhere. Like when this led me to these just 7 circles here could be infinitely at different sizes. But this channels that are here, these are cubes right here, and these are octahedron in these cubes. And we're going to find the center. I'm just going to pick a point, because why not just pick the center of the diagram? Because we've got to kind of start somewhere. And I know that, you know, the Cathara question, I have a quite a few videos on the Cathara grid and the crystal spiral, so I like to revisit this every once in a while because it poses some very good questions of where is the center, where's the source spiral coming from, and this source spiral of the golden spiral is everywhere on the surface of an octahedron on a sphere, so that's pretty big news. And it is also at the center of this diagram because these long radiating lines which go through this blue, I'll have to move this other item first, but I'll show you the golden rectangle. That golden rectangle runs through these lines and extends all the way out and divides the outer edge of the cube into the golden ratio. So I actually made this little model here. We've got some models to show at the end. So here it is. That is divided into golden ratio edges. And if I extend the line across to this edge over here and down over here, that gives me the center point based on the golden ratio right at the heart of this cube, which has a sphere in it, which is the octahedron. And now this spiral is emanating from the center of this because of the golden ratio. So this is it from the side. So let's just look at this a little bit more. So I'm just using an arbitrary center because I'm saying all these points are, but there is another octahedron in here that is made up of, it's right here outlined in blue. Okay, I'm gonna move this out and we're gonna do this because this is one large octahedron made up of 6 little octahedron. This is, you know, the basics of sacred geometry of just 6 octahedron. This is the cube octahedron. This is the cube. This is all these things. This is classically designed right here in the circles all meeting at the center point of this. And I was just saying that the spiral can emanate from any point along the surface of the octahedra, these blue octahedron, right? They can emanate from any point. So I'm just saying, hey, they're all 6 circles meeting in that center point, all 6 of them, in a very simplistic way of looking at it, are contributing to the center point of a golden spiral, okay? Really simplified view, but it is a source. It's coming from source. This golden spiral, as Cathara cheilontics say, is just off to the side. It doesn't fit. Yeah, it's off to the side because it's showing you that the spiral itself is on a sphere, which is a point in source. And now we've basically saying that each of these octahedra are, I'll repeat it again, they're part of the golden spiral coming off of 6 of these spheres around these octahedra are meeting in the middle because we know that this spiral can emanate from the surface edge of a sphere, and there's 6 of them, and they're all contributing or sharing this spiral, okay? I don't know if that's how it maps, works out, or how they share things like that, but it's making sense in the visuals, and it works out in the sacred geometry. And we're going to have some fun with this because we're going to flip a spiral around and we're going to say there's 2 spirals and we got this cool vortexy thing going on, and we're going to do more of that because I'm going to go and I'm going to flip the other one over top, and now I've got 4 golden spirals and I've got a cool little Maltese cross type thing showing up, at least part of it, but I'm going to do the rest of it in just a moment because I'm going to now take that, rotate that whole thing 90 degrees, and there we go. Now we've got 8 golden spirals. It could be 48 because I'm only showing projection towards us in one direction. But remember, we've got off to the left, we got to the right, we got up above, we got down below, front and back. So we got 6 sides going on here. And now we've got this, outline. And this was very exciting to me this morning because this shape I talked so much about. This is 2 overlapping golden rectangles. And the 2 overlapping golden rectangles are this is what I talked about in my last video. This is the overlapping of 2 golden rectangles based on the golden cube octahedron. So the golden cube octahedron was a little cube octahedron shape that I created. It had a golden rectangle face, and then I rotated one this way, and then I had a crisscross of golden rectangles. That form turned into this basic elementary shape like this. It's hollow. It looks like this. It kind of looks almost like one of these Mayan pyramids with the flat top on top like that, so you can hang out on there. And then we've got this one here, which now I did 6 directions, right? 1, 2, 3, 4, 5, 6, made it look like a cube. I got all those interlocking octahedra, creating tetrahedron. I got the channels going through the middle. Those channels are part of the vector equilibrium, which are now octahedra at each of these nodes. So this vector equilibrium that's in this, the cube octahedron, that are part of these channels has a little circle at each of these, which is an octahedron, a point basically, with the channel that goes through the inside. Last video, I talked about how that might be related to the egg-carton universe based on the octahedral model of the universe. All my theories are very speculative, just following trails and dreaming upon things. So I turned this into this big one by taking 8 of these basic units, and that was just a very small little bite-sized chunk of the golden vector matrix, which had all the Platonic solids and other forms mixed within. But it's a disequilibrious vector matrix because it's the points now, it contains both basically, because it is equilibrium, because at the center of these channels is the equilibrious point. That's where the cube octahedron points are. But anyway, what I'm trying to say here basically is that the golden spirals, when I did this crisscross here, the geometry around the golden rectangles just crisscrossed, making sense, it should, right? They just crisscrossed in a way to produce this basic structural unit that I had just been working on. And now I've infused the whole golden matrix. I haven't done it, but the drawings are showing that the whole golden matrix is infused with golden spirals. So here is my overlay of my drawing, and there's the golden rectangle faces. This is the drawing of this basic unit of this, which has a little cube in the middle. And we're going to zoom in on that in just a sec, but it's a match. This fits over top of the double golden cube octahedron. And this point here, that point there, that point there, these are the octahedral points that would turn this whole thing into the classic vector equilibrium model. So we have a jitterbug thing going on here. We can slightly modify this in ways to get all our Platonic solids, plus have these open channels in between, which now at the center of this point is the center point of the whole thing, of the cube octahedron, is this central point. Let's take a look at it a little bit closer. Let's zoom into 150 maybe. So here is the basic design of those octahedral circles that I was talking about. 1, 2, 3, 4, 5, 6 would be on the back. There's the cube that's produced by them. This has got an octahedron right on the inside of this cube. And here's our first set of spirals coming off. Look at them. They're all just matching up into this geometry that is connected to this template, this blueprint, this golden vector matrix. The golden spiral just fits over this like a glove. I mean, many golden spirals, because remember, this is the mind-blowing part again, and this is so simplified. I'm just using one central point. Remember, I did 512 of these, and that was just one little center point, but this could be a center point, this could be a center point. And the whole thing has got center points, and that's the quote, right? We'll revisit that one more time. God is an infinite sphere whose center is everywhere. That's what this is showing, and whose circumference is nowhere. Well, yeah, well, the circumference of these spirals is just everywhere. It'd be hard actually probably to find where the circumference of any of these is once this really came alive, okay, other than the static drawings. But now let there be light, because now I want to get into these images, which way back in one of my early videos that I said I was going to follow the egg-carton universe. And that video just kind of laid some of my sacred questions down. That one was called Is Sacred Geometry at All Scales? Thank God. The photon was in there and the universe was in there. And this, I was just talking about this big structure in the last video, maybe being related to the egg carton universe. And now in this video, that made sense that this structure and the golden spirals may be related to the photon at our smaller and smaller scale levels. So I just took, this is a common image on the web. There's another one. I'll show you what that looks like in a second. And I've rotated in a few different orientations. So I'll show you one of them, what I thought looked cool. And of course, I'm just playing here. You know, I know other people who maybe know more about this, but I know sacred geometry as the language of light probably has some relationship to a photon. So we could see there's a geometry here. And I did them both ways just because maybe you like one more than the other. I'm not sure. This one kind of also overlays and fits nicely, showing the points of contact. So you just can study these as possibilities of where the cube might be in this and how they're outlining these different colors and shapes that are being taken with the photograph. I kind of like both of them. This one is the red one that's in that picture that is associated with that other blue one with all the other colors. This is the rotated version of that, 45 degrees, you know, and that's showing some, I don't know, loose connections here. There's a little red hash mark that's up above this that is being overlaid, that these kind of end up over there. So I don't know, is this related to the photons of light? It's possible, I'm not sure, but I thought I'd put them in there because I really think this one fits nicely over this. This looks like a rose or something, a 4-petaled flower, some sort of emanating flower. And if we counter rotated these spirals in a way that was with the 137.5 degree angle, we could turn this shape into the classic rose type of pattern with the golden spirals and put them into the sequence of numbers that will do that. So, okay, that was the big overview, quite a little journey. So I said this was going to be about the basics. And I took the basics from those simple drawing just to show from the Vesica Pisces that we started with, how we can go on to explore that whole golden vector matrix. Stick with me for a moment because I'm going to open up my iPad because I'd love to just show you the rotation of that, because these things are hard to visualize when we look around and see so many things around us in 3D. And this software, I'm thankful that I figured it out, and I might do more with it at some point, as long as I can open this for us, which seems to be, there we go. You know, it's hard to visualize many of these things, so let's just see if I can get this going for us. And if not, I'll do it in the next video. It seems to not be so happy right now. Come on. Well, I think that might be a no-go on that. Oh, wait, here we go. Okay, I'm going to try and share the screen for us. Thanks for sticking with me through that, because I think you'll really like this part of it. And as long as it reads the iPad, there it is. Like I was saying, it's difficult to visualize these things in 3D, and this will give us the ability to kind of rotate around as soon as it comes up and running. You should be seeing the screen in just a moment. There we go. Okay, you should be seeing the square view, just like my drawing. And this is the outer sphere, and the red sphere is on the inside. I've done my golden rectangle. And now I'm able to, you know, just slightly move it around a little bit and zoom in and out. So just zoom in a little bit first so you can see those points on the surface of the sphere. See N up there? N is embedded in there. And here's my point P on the surface of the sphere. And I want someone who's a real techno whiz to just really verify that. I couldn't find out what the functions are of that. So but they're pretty much right on there. And maybe that's, you know, all we need. I know that the ones on the outer surface of the sphere have been verified by Coxeter, and or not him himself, but somebody's probably done it. I hope, because they put it on a website talking about that. So here's some of the other views. Let's go into our classic Metatron's cube view, or golden circle seed of life view. But we're going to look at it as a cube, and there's our star tetrahedron inside. There is the points poking through that surface of the sphere. And now here's our golden rectangle following those points. And here's the division on the octahedron, creating that rectangle, and the other rectangle here. And right here at this point right there, that's where it pokes through this surface. So these were the drawings I was going over in there. And we can look at this from many different views. There's a cube on the edge. We could probably figure out how to draw this from this perspective. And you see where the point is poking through there. That's actually very interesting. It's poking through right there on the surface of the sphere. So I got to this, and I had to figure this out basically because I wanted to make, sure to the best of my ability that that relationship between the origin of the golden spiral, right? That's what I'm talking about. The origin of the golden spiral is on the surface of that octahedron, which can also be thought of as the sphere within the cube. They're both sharing the same vertices at that point. Okay, so I hope that helped a bit. It's tough to find that other view with my original question. I have to kind of really rotate into weird angles, but you can see just enough from that. Okay, beautiful. Well, I'm glad that worked out. And let me just show you a couple models, just once again, it was better probably in 3D because it showed you more isometric. Our 3D perspective is going to make that look closer than it is, when in fact there's quite a distance between that point. We got that, we got our, remember I could turn that into the dodecahedron in the sphere, right? So all the vertices are touching there. That's when we go to fivefold symmetry. And we got our octahedron, which is not the same scale as it, but that is also in there. And just remember, we're looking at the majority of those drawings like it's a square with a cross in the middle. Here's the view like that. Here's the one classically seen in Metatron's cube. And from that view, it won't look like any of the points are touching the surface of that sphere, but they will like this. Okay, so the other models, from a distance you were looking at, here's the big golden vector matrix one with just a cubic one without the fivefold symmetry. That's got an octahedron, or at least one in the middle that I did. So you can just see. The very interesting thing about this is just remember, these are all channels that go through. As you can see, I'll line it up with our Sri Yantra in the back there. There it is. See, little triangle in there. That is a channel that will just go on and on and on. And as I was saying, that is making the cube octahedron. There's 12 of those around this, and these are those golden rectangle faces. And it came about because of this little shape here, golden cube octahedron. Okay, so this is kind of an elaboration of this, and I guess the big takeaway is that that golden spiral can show up anywhere on the surface of that sphere that is around that octahedron or inside that cube. And what is the point really? If we shrink that down more and more, back up further and further away from this circle, this sphere, right? Keep going, going, going. That will look like a point at some point. And that could just be radiating these spirals out, thinking it's one point of source when the source points are everywhere. So I've just isolated one. Here's this last model too, just demonstrating that you can do the crisscross of lines to find the origin of that. Probably do some more research on that. And very simple, basics, just get back to the drawing. This is such a simple technique to do. I already have a video out that does it. Maybe you could follow along here. Classic vesica Pisces. Right, square in the middle and cube around the outside if you prefer to draw it. Crisscross of lines. There's our central point meeting on there where the spiral will emanate from, and there's the spiral. So if you enjoyed this video, please subscribe. If you want to learn to draw some of this, I have a Patreon site which walks you through the starting with basics, right, and working up from there. If you've never drawn before, that's very easy to get started hand drawing this. I also have apprenticeships to look into on my channel. All this will be in the description. So I just want to really thank you for watching, and I appreciate you spending this time with me. All right, much love and peace.